Keeping the pump station operational throughout construction and ensuring it continues to operate in even the most extreme situations was a major emphasis during design. A highly detailed vulnerability assessment was conducted, where every possible scenario of what could go wrong was evaluated and a safeguard was designed to address it. The entire facility was updated to increase reliability through comprehensive redundant systems.
We identified in the Elizabeth Lake Pump Station all the areas where we could or would be vulnerable or had already been vulnerable. And also we looked at other facilities and we looked at those particular aspects of vulnerability and then attempted to and did address each of those as it would relate to the Elizabeth Lake Pump Station.
Construction sequencing was critical to continued operation of the pump station during its 2-year rehabilitation. Equipment had to be operational and accessible. Work was coordinated in 7 construction phases to ensure that the facility was always operational. During the first phase, a submersible pump was added to the wet well. This pump provided a critical early action fix to prevent the possibility of overflows and was integrated into the long-term solution. It is the only pump capable of operating underwater, a must to keep on pumping if an extreme event floods the station.
We added number 6 pump, which is a submersible pump. It's a pump that's designed to operate underwater, and that's in the case of a structural failure between the dry well and the wet well, we have a piece of equipment that's designed to operate underwater to tide us over until we can make repairs.
2 pumps were taken out of service. New hydro-pneumatic systems were connected to the process equipment to enable remote operation of the suction pipe isolation gate valves. These systems provide a secondary process water source to operate the facility even in the event of a power failure.
The reliability of the pump station has been improved by providing a backup emergency generator and also by providing a secondary force main. The entire pump station can be operated from this backup generator.
A new 24-inch secondary force main was installed to transport pump flows to the Clinton-Oakland interceptor. This second discharge route to the interceptor is critical, providing the ability to take either force main out of service for inspection or repair.
The secondary force main provides greater flexibility for operations because the operator, the pump maintenance mechanic, can direct flow to either force main if you're inspecting one, or if a contractor, outside contractor, does some damage to either one, you can direct to the other one.
Steel sheeting was installed and excavation of the exterior pipe vault started. The vault was designed to house piping and isolation valves that can route flows to either or both force mains. This provides greater flexibility in operating the pump station. The piping configuration within the station was also changed. The main piping or header system was eliminated, providing greater flexibility for the operator to route flows and isolate a pump if necessary. Construction of the new header system was completed in Phase 2.
The biggest single improvement that I see, which actually is 2 improvements, is the redundant header system and separate headers for each pump. So we've made failures of single components, not an entire station failure. And through the design process, we were able to have some backup and have some redundancy in pumping. In the unlikely event that power were to be lost at the station and also that the generator were to fail, we have the ability to use an external pump and connect it to the force main through this connection, providing us with continuous pumping.
5 new centrifugal variable speed pumps were installed to allow pumping to keep pace with influent flows. The submersible pump was connected to the new header system. New plug valves were used to reduce the maintenance headaches caused by the existing cone valves that jammed frequently. The new valves will shut off immediately in the event of a power failure and begin operating again when the power is restored.
We're on the 2nd floor of Elizabeth Lake Pump Station. This valve and piping is connected to the submersible pump, the number 6 pump that's on the other side of the wall. And that's the pump that is designed to operate underwater. That's its function. Were this area to be flooded, or if this wall were to be breached in some manner, the submersible pump would be able to run and continue to remove flow from both this area and the wet well until repairs could be made.
The new pipe vault was completed to connect 3 of the pumps to the new force main. The remaining 3 pumps were replaced and the existing single header piping was removed. With the pumps connected to the new force main, the existing force main could finally be inspected after 40 years of service. The inspection confirmed the piping was generally in good condition, but leaking seals required replacement.
During inspection of the force main, we found basically construction-wise the force main was in good shape. However, there were 3 leaking seals on the system that could have provided future sanitary overflow in the system, and that was repaired.
After the remaining 2 pumps were installed, the existing 30-inch force main was reactivated and all pumps were operational. A new generator was installed to run the entire facility in an emergency. Backup portable generators are also available for the smaller pumps.
Okay, this generator was installed as part of the construction project, and it actually fits in place of an older device, that natural gas engine that ran a single pump in the building. This generator was designed to operate all equipment in this building at any given time, including controls, heat, the elevator, louvers, and odor control equipment. And this is our primary backup to Detroit Edison Power. If Detroit Edison Power were to fail, this generator would start automatically and it can run the station indefinitely. In the unlikely event that the generator was to fail, we have the ability to hook up portable generators, pump number 1 and 2, inside the pump station and to continue the pump.
The pump station's electrical system rehabilitation included a new main control panel with a programmable logic controller to operate check valves and pumps. All electrical conduits, fixtures, receptacles, and lighting were replaced. Night lights were added on each level to provide low-level lighting at all times. The pump station is monitored 24 hours a day, 7 days a week. Flow meters send continuous readings to Oakland County Drain Commissioner staff and the main control panel at the pump station. If a problem occurs, an alarm goes off. The maintenance staff is sent to the station to diagnose and repair the problem to keep the station operational.